It's my pleasure to introduce two visionary leaders in the field of neurotechnology and therapeutic innovation, Doctors Jess Broeng and my Nguyen, co-founders of Optoceutics. Jess is a renowned serial high-tech entrepreneur and professor with a PhD from Technical University of Denmark, and he has co-authored over 250 scientific publications and holds 22 patents, reflecting his extensive expertise in photonics and entrepreneurship. As a fellow of the International Society for Optics and Photonics, Jess brings a deep understanding of light technology, which has been pivotal in developing innovative solutions for healthcare. His work spans basic and applied research, business development, and high-tech sales across the globe. Dr. Mai Nguyen, CEO of Optoceutics, is a trailblazer in neurotechnology, specializing in non-invasive light therapy for treating Alzheimer's and dementia. Her leadership combines rigorous scientific methodology with groundbreaking therapeutic solutions driven by a personal mission to improve lives. Optoceutics' pioneering work focuses on using gamma stimulation therapy and digital biomarkers to advance brain health. Today, they will share with us the extraordinary therapeutic powers of light, highlighting Optoceutics' innovative approach to brain stimulation technology. Their work offers new hope for millions affected by cognitive decline, and we are honored to have them share their insights with us. So let's have a luminous welcome for Jess Broeng and Mai Nguyen.
Thanks, everybody. Yes, would you like to introduce yourself first?
Yeah, I can do that. Thank you so much to all the Rotaries. It's really a pleasure and honor to be able to meet you here and speak about this. And a special thank also to Buddy, which I met when I was a visiting professor at UC Berkeley back in 2016 and 17. That's also where I met one of the world's brilliant PhDs from that school, and we co-founded Optoceutics together. So that was a short one. Thanks for the introduction, Buddy, and really great to be here. So Mai.
Yeah, thank you everyone for inviting Yas and I to present at the Rotary Club, and it's quite an honor to be able to present this to you guys. And thank you, Buddy, again for inviting us. I'm excited with the community as I do live here in the Bay Area. So excited to meet you guys in person one of these days. I will start by introducing Optoceutics and a little bit about a personal story for me. And feel free to, I think, interrupt and ask questions. I believe it's much better to have an interactive environment while I'm presenting this. So yeah, just raise your hands or have Buddy interrupt me. But yes, I'm Mai Nguyen. I did my undergraduate and graduate degree at UC Berkeley, undergraduate in microbiology and graduate studies in neuroscience. And I'm the CEO of Optoceutics, which we have a light-based brain stimulation to prevent and treat cognitive decline. As with every single presentation that I make, I always want to give thanks and having the understanding of why I do everything that I do. It's because of my father, who passed away in 2020. He's one of the reasons why I do a lot of the research and going through the science here. And again, I'm doing this for my mom. This is her when she was only 35, and now this is her in her 70s. She's holding my niece, and something that's really important for me is ensuring that her brain health is going to be up to sort of alertness and everything as she goes on into her golden years, is what I like to call it. And so, as you guys know, every 3 seconds, someone develops Alzheimer's. So by the time I finish saying this, there's another person who has already been diagnosed with Alzheimer's, a disease that not only strips a person of their behavior, their personality, and their meaning, it also destroys families. I know this as I experienced firsthand the toll that it took, the mental and physical toll that it took on me and my family while watching a loved one slip away. I'm not alone in this, as many of you have also had friends and family going through Alzheimer's and dementia. And as the rates continue to rise today, we still don't have a cure. And yet pharmacological treatments are often ineffective, expensive, and come with significant side effects. Therefore, I do believe that in the last 20 years, a lot of people who have been diagnosed with Alzheimer's believe it's a death sentence, because in the last 20 years, we haven't really had a cure. But that doesn't have to be the case today with advances in blood biomarkers and other diagnostic tools. We're able to understand and learn that the brain begins to decline 15 to 20 years before symptom arises. And in combination with neurological stimulation, in particularly light stimulation, and of course, sound and music that Buddy had just said earlier, we're able to unlock new ways to prevent cognitive decline and ultimately stop the disease in its tracks. How are we doing this? With recent studies as early as 2016, scientists have utilized the eyes in mouse models and in human as a gateway to brain activity, which are often observed to decline, especially in the somatostatin. Those are the neurons that die the earliest in Alzheimer's, as well as they are the ones that are responsible for gamma wave. So now we want to understand this and target the root cause of Alzheimer's by using the eyes and light to not only restore brain connectivity, activate neurons and microglia to decrease tau and plaque, which have been the hallmark of the disease, as well as preserve myelination. And we've seen this in our studies that by using light, we can induce a synchronization in the brain to impact the disease progression. Before I move on to my next slide, if you are sensitive to flashing light, I would suggest you looking away. This is what 40 hertz gamma looks like. It's uncomfortable, unbearable to some, and can induce other side effects such as nausea and even migraine in a lot of individuals. So its application adherence is quite hard. I'm going to move away from that just so that you guys don't get blinded. So what we did at Optoceutics is that we patented a invisible spectral flicker light. As you can see, that this is our device currently. On the right panel, there is a color panel that shows the strobing here at this green olive range that you can see that the light is strobing, but to the eyes, you actually don't detect it. We've also conducted our own research in 40 hertz stroboscopic and invisible spectral light and have found that by utilizing our light, it can still stimulate the brain at 40 hertz while synchronizing and improving the brain waves in individuals that have been tested. Along with that, we've also built an application that allows us to, in combination, track the adherence and compliance of the individuals and have an impact assessment to show the progress of the individuals. In the future, we would also like to work with provide a value-based focused platform that we understand and use with the patients, the caregiver, as well as the providers in order to continue conducting research and understanding how we can better treat and learn about the diagnosis versus the combinational treatment effects of what we are doing today. Right now, we are doing a dual path strategy. What I mean by that is that we wanted to bring the light therapy to the comfort of the homes of the individuals while providing a gentle, accessible, and comfortable at-home treatment. Why are we doing this? Again, going back to my dad, is that he passed away while we were in clinical trials, our first phase clinical trials. He never got a chance to utilize this device. And it brings me back to always understanding that something that is non-invasive has little to no side effect. I decided that it was the best thing for me to provide this in home today for individuals who might not have symptoms or even have early cognitive symptoms, and to also better understand how we can impact them in their homes while collecting data and learning how we can improve our research in home, as well as improve our device to better interact with the individuals who need it most. What's interesting about the device is that you don't have to look at it. You can be reading a book, having a Zoom call like what we are doing today, or having dinner with your loved ones. And that's something that we continually try to improve. We are currently in phase 2 clinical trials with Alzheimer's, moderate to mild Alzheimer's patients as well, in order to continue our research integrity. With this, we have a team of course, with my CTO and Jesse and Jeff. We're doing this not only to provide innovative research and partnerships, so we have a team that can do the go-to-market side, but we also have world-class key opinion leaders and clinicians and expert advisors, one of the leading blood biomarker researchers in the world, where we are going to begin our phase 3 clinical trials. In Sweden, we have Jeffrey Cummings, who is the renowned Alzheimer's researchers in clinical trials in humans today, as well as various other research partners from UC Berkeley, DTU, and UC San Diego as well. Along with that, we have a lot of partners that we're working with in hospitals and clinics, as well as foundations who have helped us to date to not only fund our research, but also help us in our clinical trials. To date, we have had not only our own clinical trials, but other publications, over 36 publications supporting the research and the technology, and 11 of which is our own. We have 26 patents and 7 as granted, as well as we're also a Class 1 medical device in the EU, while a direct-to-consumer general wellness product today.
Hi, I know that Alzheimer's is a large percentage of the dementia, but it's not the only form of dementia. Does this work for other forms of dementia or only for Alzheimer's?
As this is something we focus purely on Alzheimer's, because we have to focus in not only our preclinical trials and clinical trials. There has been other studies from other research institutions like Georgia, MIT, that have looked at other forms of neurological desynchrony and dysfunction in the brain, such as MS, Parkinson's, and other mental health. So we have those data and understand that, but with limited resource, we have to focus on ensuring that we have the proper clinical trials for one of the forms of dementia.
Yeah, maybe Maya, I can add to that one here. It's a quite new field in neuroscience, and getting a lot of traction now, and attention from the established research community within neuroscience. The interesting thing is that we can go in and stimulate the brain, actually stabilize the neurons that keeps our brain healthy at a very early stage. So when you work with pharmaceuticals, you're typically working with a brain where many of the cells have died. So this stabilization early on has some promises also in other areas than Alzheimer. Alzheimer is the first one we're looking into. So we have to be careful when we're dealing with science, but I can say a lot of people are encouraged to expand the scientific area way beyond Alzheimer, even though to epilepsy and many things where it's about having a healthy brain.
I have a couple of questions. First of all, I'd like to know if you could tell us approximately how many people do you have in clinical trials currently? And then the second question is, it sounds like your innovation would be helpful for people who are starting to have symptoms of Alzheimer's or dementia. And my question is, how are those people going to be identified by physicians or others so that they can get the early treatment that might slow down the progress of the disease?
We're in phase 2 clinical trials right now in Denmark, and we have 64 patients with mild to moderate Alzheimer's, as well as minor cognitive impaired. This is our third year in the trial, where we follow the patients for 6 months, 3 months pre and 3 months post. And we've published so far our pilot and phase 1 data of positive indication of slowing or stopping of the progression of the disease. I do think that a lot of times right now, I can give you an example of our product that's actually on the market in the US since beginning of January of last year. people are actively looking for preventative solution as well as solution, especially in terms of when their physicians are diagnosing them with either a genetic disposition, which is APOE4. The other one is they get diagnosed with MCI, which is minor cognitive impairment. The third thing is with the advancement, I think I spoke to this earlier, advancements in blood biomarkers and early detection tools, people are oftentimes now seeking much earlier understanding of their brain age. And so for us, understanding that and working very closely now with outreaching to neurologists and other gerontologists and nurses and people in the field to not only educate, but directly interact with the community who wants to understand more about their brain age.
Good morning. I have a question. Have you worked at all with Heather Sanderson down in San Diego? She just wrote a book called Reversing Alzheimer's and is having quite a bit of luck with diet and lifestyle interventions.
No, we haven't worked closely with Heather. I know of her and some of her research. I would love an introduction. I think right now we are seeking clinical trial phase 3 sites that we can have partners to recruit and run our clinical trials with.
Good luck.
Thanks.
You used the term myelination on one of your earlier slides. Can you briefly explain what the interaction between myelination and cognitive decline is?
Yeah. Yes, I think you were going to speak. Did I interrupt you?
No, that's fine, but I don't know if you want to show the cascaded model. I have the slide. Yeah, so interesting. When we look at Alzheimer, also the question before, how do we actually get to the relevant people early on? Because it's before you're actually diagnosed by the Alzheimer. So what happens if, as you develop Alzheimer, 15, even 20 years before, is actually a cascaded effect. So in the red curve that I hope you can see, it's actually, we have some deposits in the brain, some amyloids. There's also tau, which is indicators we can see from blood samples. And then there's neurodegeneration, brain cells actually dying, and then you see the cognitive decline. So the blue one we have in the beginning here, that's actually those brain cells that we go in and stabilize, that are sort of over-firing. So the question before was actually that we can stabilize those brain cells. So the right term, myelination, I consider it like an insulation within the brain, and that is sort of getting burned off as you have this activation of the brain in the beginning. So our light actually pushes down that overstimulation and keep the insulation in the brain cells through the brain cells more intact. Now you can put in the scientific terms. This was probably more layman.
Yeah. So typically, demyelination occurs as we age. Especially myelin is important for electrical signaling in the brain, which has rapid fire signaling, which they can communicate from neurons to neurons. You do see, because of the loss of function or the demyelination, those signals don't get transferred downstream to other areas of the neurons, which is providing information and nutrients to those neurons. Oftentimes, as those die, the neurons begin to die, the demyelination. So what we're doing is that we're entraining the brain to send proper signaling and decreasing inflammation in the brain by recruiting microglia to reduce those inflammations. And so oftentimes you do see in clinical cases where if you have high anxiety, high depression, or even diabetes, they have increase in glycogen-like peptide 1, which also increased the risk of cognitive decline by about 18% in diabetes and 33% in those with ADHD and anxiety. So how do we do that? By catching these sort of prodromal disease much earlier on, reducing the inflammation in the brain and maintaining the myelination within those neurons to keep them healthy and continually keeping the brain cognitive and alert. Does that answer your question? I'm sorry. It might be a little too technical.
Thank you. Question I have is, many of us who are approaching my age and a few others in the room, we are quite forgetful of more so than what we used to be, 10, 15, 20 years ago. How do we recognize if a good friend, a family member, or somebody, the difference between just forgetfulness as we age and what might be determined as some type of serious cognitive problem?
Yeah, it's quite interesting. It's never the individual who recognizes that they have a sort of cognitive impairment or decline. It's always the family members, their friends who often begin to they understand your behavior and trends a lot more in terms of repetitive interactions. Forgetting keys one time is okay, but forgetting keys or turning on the burner multiple times or repeatedly saying the same story, there are also other ways where people tend to have a decline in reaction time alertness. Again, sleep and circadian rhythm is extremely important for the pathology of Alzheimer's, as the more impaired your sleep is, it's sort of a cyclical effect. And so you do see those trends, but today you can also go in. So I can say this, that I don't know if it's still the same case, but years ago, a doctor cannot tell you that you're having early signs of Alzheimer's because it's unethical, because we don't have a cure. So you actually actively ask a physician or a nurse to go and do a ADAS-Cog, which is a memory test, in order to understand if you're going to have Alzheimer's. Because ethically, even if they notice it, they're not allowed to tell you.
Well, that's a scary prospect.
Could you maybe talk a little bit more into the p-tau test that we expect to come out within the next year, because that can be quite a game changer in relation to this.
Of course. One of the latest sort of findings in research today that has been done by Henrik Zederberg, one of our scientific advisors, is the p-tau 217, which is a blood biomarker that can detect through your blood early signs of Alzheimer's or dementia. So they do various testings in Sweden. That technology is going to come out where there is an association through the university where they send in-home blood collection tests, and then you send it to them, and you can actually understand your prognosis in terms of your disease progression. And so we are in hopes of that running our clinical trial phase 3 with Sweden in order to not only detect, but hopefully prevent and treat the disease as well.
Those are all exciting prospects. I'm thinking kind of way down the road. Do you envision, since if I understood you correctly, this process can work on an individual almost passively, that they can be close to this light source flickering and not even notice that it's flickering, and it's doing the therapeutical function without the patient having to do anything?
Yes.
If that's the case, do you envision down the road the possibility of this being a household item where you just put it in your living room, and while you're, I don't know, watching TV, reading a book, you're getting therapy, advanced therapy to prevent Alzheimer's?
Yeah, the future is now. We do have the device where you do just put it in your living room, and you're sitting there watching TV. And because you need to utilize the treatment or utilize the device 1 hour a day, every day, minimally, according to our research, having something like this that can just be integrated into your daily living while actively stimulating your brain is important. So we have that now on the market to understand sort of the real world data. Eventually, we would hope that we can build it into something like your entire home lighting. But right now, as a first off, we are offering it as a small device that you can just plug in at home.
Yeah, I was very interested to hear you talking about neuropsychological testing, to be involved with this. I'm a recently retired lawyer who did a lot of probate litigation and a lot of litigation around the issue of did dad have capacity to sign that will, leaving everything to the housekeeper? You laugh. I'm not kidding. Do you, the question, I suppose, would be how much work do you do with neuropsychologists, and also an observation of the testing that you're talking about that that medical doctors can administer, because what they can administer is a lot more limited than what neuropsychologists can. That's just the licensure requirements. That I think the test you're talking about is the one that goes up to a 30-point scale. And it's sort of arbitrarily set depending on who you're talking to. Somewhere around 21 or 22, you're okay. Below that to about 19, you're mildly impaired. And the thing that everybody else here should observe is it's not just a matter of what your absolute scale is. It's a matter of change. You might score a 23 now, and everyone said, you're fine. But if your cognitive functioning was such that you scored a 28 or a 29 5 or 10 years ago, you've got issues. And if you don't have that background, we might not know, which further complicates trying to get to the, hopefully keep people from getting to the point where what you're doing can't help or minimizes the help. But anyway, excellent talk. Thank you very much for being here.
Good question.
Yeah, I completely agree with you. In our clinical trials, we mainly work with a neuropsychologist who administer all these tests. One of the things that we also look at is what is the latest in research is called time saving, right? And exactly what you said is that if you had a 28 3 years ago, and now you are at your typical 21, 20, it means you've declined in the last 3 years. So understanding that and saying, okay, during the trials now, have we seen a typical decline that is usually observed in individuals with Alzheimer's? So typically, let's say you go from a 20 to 17 within a year. Are we able to help and aid slow down or stop the progression where you're still at, let's say, minor cognitive impaired after a year? That means we time save 12 months of your brain cognition and ability to be at that stage that it's at right now. We're still continually learning if it can even slightly improve, but we do know that that's something that we have to continually learn and actively work with neuropsychologists, as well as neurologists and gerontologists, as well as the family and individuals. An understanding is that no matter how your brain changes, if it doesn't actually translate to behavioral and neurological sort of cognitive change, it doesn't really matter. And that's what we want to ensure here.
Hey, thank you both. You guys are awesome. I want to say to everybody, Mai makes a wonderful tiramisu, so I'm still enjoying that. And you're invited to dinner. And both of you and Jess, I hope the triplets are doing okay. They said we have what? And it 1, 2, 3. So yeah. So anyway, big question. Oh, one more thing is you're both invited. Get a nice flight around the bay next time you're anywhere around. So got that. All right.
Thank you,
the question is for everybody, what was the biggest challenge of this whole journey to put this out there? I think we'll all appreciate that. Thank you so much.
We probably have different takes on this one, but I can say one. One is actually the response we had from the established community within pharma and biotech, because you're used to dealing with these kinds of very serious diseases with small molecules. And we don't bring a small molecule, but we're completely scientific and science-based also. So it was actually a challenge to me to see, even with my science background and started a number of science companies, there was quite some conservatism. That seems to change at the moment now, because we can enter this early stage and probably make a real difference. That's really what we're betting on. Go in and treat Alzheimer's where the brain is still functioning, and you can push these things aside. So the barrier was to getting recognized also in the established and we're getting there now.
Yeah, buddy, I live in Berkeley, everybody. So when I'm not in Denmark, so I'm happy to go to your Rotary Club one of these mornings and bring tiramisu if you'd like. I don't provide the coffee. Please bring your own coffee. But yeah, I think one of the challenges for me, especially if I'm looking back from 7 years ago when we first started till today, um, it was very difficult in 7 years ago to get people to sort of be open to the idea of something in terms of light that can impact the brain, not only within the scientific community because it was such a new discovery, but even with the various partners and institutions. And today, even though there's over 30 publications on the impacts of light and sound and neural stimulation, it's still a challenge to educate and have the general public understands the various impact that these simulation can have, especially when you bring out a light and they're like, what is this? It looks like a normal room light, right? But the hardest part of it is building something that is so simple in terms of looking, but extremely complicated, like a quantum physics or a quantum computing, that people just take it for granted. So I think it's the challenge as well is coming from a scientific nerdy PhD background and being thrown into sort of trying to talk about this in a more business and interaction. But yeah, I do hope that by doing these sort of talks and educating individuals and communities more about the research that are out there, that people will become more open to trying new things. Yeah.